Ready to do some calculus? Let's go. F of x is equal to x3 x for f of x is equal to x for x is less than 2 and is equal to 3 for x is greater than or equal to 2. Okay, so if the function f is defined above, then what is the integral of f of x from -1 to 4? Okay, so the good thing is that this type of questions is not hard, but it's also requires you a little bit of thinking, because we didn't provide any x value, any like function, the y values when x is equal to -1 or 4. So what can we do? Well, the good thing is that 2 is in between -1 and 4, right? So we can divide this into 2 integrals instead of 1. So I'll show you what I mean. This is our original one. We can put it in here like this. Okay, so this is pretty good because we have 2 in here, and we also know the each corresponding values of the function when x under different conditions, but it's always around 2. Either it's less than or greater than or equal to 2. So it's good. So this will be for -1 to 2, because it's less than 2, so the whole function will just be x. And for 2 to 4, because it's greater than 2, so the whole function will be 3. And just take integrals for both. And we can find the definite integral for this, which will be 4 divided by 2 minus 1 over 2 plus 12 minus 6, which will be 2 minus 1 half will be 3 half plus 6, so 12 over 2, which will be 15 over 2. So this will be our final answer for this question. Okay, let's keep going. This one, integral of e to the x cosine e to the x plus 1 dx. Okay, what's this? Well, for this thing, the quick thing is to use the u sub. Pretty important topic in calculus. We can make the u equal to e to the x plus 1, so du will be e to the x dx. So the original integrate will be this, because e to the x dx will be replaced in here, right? This and this can be replaced with du. So this will be sine to the u plus c. And we can replace u with e to the x plus 1, which will be sine to the e to the. Okay, this will be our final answer. Good. Let's keep going. Okay, so at time t, a population of bacteria grows at the rate of 5e to the 0.2t plus 4t grams per day. So where t is measured in days, by how many grams has the population grown from time t equals to 0 days to t equals to 10 days. So this is where the population of the bacteria grows. So we want to know that by how many grams has the population grown from t equals to 0 days to t equals to 10 days. Okay, so we're giving us a rate. This is a rate. why? Because the unit. If it's something per something, like 99% of the case, it would be a rate. But the question is asking us how many. It's amount. So changes from rate to amount means that you have to take the integral of the function. So from 0 to 10, we're going to take the integral of this. So we can divide this out into two separate integral, which will be from 0 to 10, put a 5 out because it's a constant, and plus 4, same thing. Okay. So from this point on, we can start by taking, we can start integration, which will be this e to the 0.2 t 4 times t squared. Will be 5, and this will be so this will be 25 times e to the square root minus anything raised to the zero's power will be 1 plus 2 times 100 minus 0. So it will be 25 e to the square root minus 25 plus 200, which will be 25 e to the square root plus 175. This will be our final answer. Okay, so it's not super hard for this question, but the calculation, it takes a little bit thinking. Yeah, so that's good. Okay, let's keep going. So, for this question, we're asking to find the solution of the differential equation dy dx is equal to y secant squared x with initial condition y pi over 4 is equal to -1. Okay, so the solution is what given the initial condition? Well, we can use the cross multiply first. This basically is this over 1, so it will be dy is equal to y secant squared x dx. We can divide both sides by y, so move y to the left side, take the integration. This will be natural log of absolute value of y is equal to tan x plus c. And the reason I didn't put the c in here is because that the c can be combined at the end, so I just kind of like skip a step in between. But if you want to put a c right here, you can, and just don't forget to put the c to the right side. And we can raise to the base e power. Y is equal to, remember that when you like plus something, it basically means you multiply that thing. Like when you plus something in the exponent, it means that you multiply that thing raised to that power. I'll show you. Like it basically means this, right? So these two are the same, and because that c is a constant and e is also a constant raised to a constant will be a constant. So we can also replace this with a big C, and we can always put the constant in front like this. So I think this is a pretty good place for us to stop and put the initial condition into the function. So this is x, this is y, so -1 is equal to c e to the tan of pi over 4, which will be -1 is equal to c. So tan of pi over 4 will be 1, so e to the first power will just be e. So divided by e on both sides, we get c. So at this point, we can put the c back into our function, which will be this one. So it's kind of like weird. You have to like put it back and forth a little bit, but it's what it is how you do this type of questions. You need the initial condition at this step to find c. After you find c, you have to put the c into our function to get our final equation, which will be like this. This is c, so times e to the tan x, like that. But we also know that so e in here can be canceled, which will be negative tan x. Wait a sec, but it does not seem right. This is c, and so this will be negative e to the tan x divided by e. So yeah, okay, so don't do that. Don't cancel out the e because they don't have the same power. So instead of doing that, we can change c into negative e to the -1. So it will be a lot more clear, I think, times e to the tan x. So it will be negative e to the tan x minus 1, like this. Or like if it's a little bit confusing sometimes, it's either like tan of x minus 1 or tan x minus 1. So I think in order to avoid confusion, you can make it like this: y is equal to negative e -1 plus tan x. So like that.